Dear students, today we will take one more part of statistics in economics, that is measures of dispersion. In this topic we will learn different methods of dispersion such as range, quartile deviation, standard deviation. What is meant by dispersion? The meaning of dispersion is spread out. In dispersion, we come to know the variability of data. That is, how much there is variation in the given values of data from the average. It shows to which extent there is variation in data, there is variability of data with respect to the average of the given series. This is the meaning of dispersion in statistics. According to Dr. Bowley, dispersion is the measure of variation of a variation of the items. This is the definition of dispersion in statistics given by Dr. Bowley. He says that dispersion measures the variation of a given items in the given distribution. For example, if we have a data on income of family A, and it is given as 22,000 and 22,000. Suppose there are two family members in a family A who earns per month income 22,000 and their total is equal to, that is, we can also calculate the average income, the arithmetic mean of this data denoted by x bar. X bar denotes arithmetic mean. It represents arithmetic mean of this given data, which is equal to sigma x divided by n. We have also learned this topic in our previous lectures. Sigma x means summation of x values. This is x1, x2, x3 and x4. It will be equal to, this will be x1, x2, x3 and x4. Different values of variable. The variable is income of a family A. It will be equal to x1 plus x2 plus x3 plus x4 divided by n. It will be equal to x1 is 22,000, x2 is also equal to 22,000, x3 is 22,000 and x4 is also equal to 22,000. Divided by n. N means the number of observations, number of items in a given statistical series. And these are 1, 2, 3 and 4. Income of 4 persons in a given family. It will be equal to, add up these values will be equal to 88,000 divided by 4. It will be equal to 22,000. This shows the average income of this family. Average income of these 4 persons. In this data, you will find that there is no variation in the given data. There is no dispersion in this data. Or in terms of this average value, there is no variation. There is no dispersion. Therefore, in this case, there is no dispersion of data. No variation in a data. No dispersion. Zero dispersion in a given data. Now we can take income of family B, which is given as 20,000, 21,000, 23,000 and 24,000, and their average income will be calculated with the help of the formal arithmetic mean in case of individual series, that is x bar equal to sigma x divided by n, where sigma x will be addition of these values x1, x2, x3 and x4. It will be equal to 20,000 plus 21,000 plus 23,000 plus 24,000 divided by n, number of observations. In family B, there are 1, 2, 3 and 4 family members who earn these different incomes per month. And 20,000 plus 21,000 plus 23,000 plus 24,000, it will be equal to 88,000 divided by 4. It will be equal to 4 to 8, 4 to 8, 22,000. The average income of family A is 22,000 and average income of family B it is 22,000. There is no difference. But in terms of dispersion, in terms of variability of data, in family B you will find out there is variation, there is variability, there is dispersion in the data. These values, they differ. They vary from each other, or in terms of their average value, they also vary. 20,000 it varies from 22,000, 21,000 it also varies from 22,000, 23,000 it also varies from this value, and 24,000 it also varies from this average value, average income. Or between these values they also vary. Means there is some dispersion, there is some variation in the data. However, the average income of family A and B is same, but in family A there is no dispersion, no variability in the data, but here there is variation, there is variability, there is dispersion in the data. But not too much dispersion. If we have income of family C equal to 10,000, 16,000, 24,000 and 38,000. Their average income will be equal to sigma x, that is summation of x values, where we can denote this income by x, and these are the values of variable x, which shows income of the family C, x1, x2, x3 and x4. It will be equal to sigma x divided by n, that is total number of observation, total number of items in a given series, which here means the number of family members. It will be equal to 10,000. Sigma x will be 10,000 plus 16,000 plus 24,000 plus 38,000 divided by total number of items in a given series. That means total number of family members, 1, 2, 3 and 4. This is the income of 4 persons. It will be equal to 10,000 plus 16,000 plus 24,000 88,000 divided by 4. It will be equal to 22,000. Here again you get the average income equal to 22,000. There is no change in their average income, but in terms of dispersion, in terms of variation of the data, variability of the data, spread out of the data, you will find that in family C, these individual values, they differ, they vary much from this average value. 22,000, 10,000, it varies much from 22,000. Same is for these values. Like 38,000, it varies much from this 22,000. Means there is variation, there is dispersion in this data, though their average income is same. And here there is no dispersion, no variability of data. Here there is some dispersion, though not much. Here there is highest dispersion as compared to this, the income of family B, because these values differ much higher than their average value, that is equal to 22,000. Or between these values, among these values, they also vary. There is dispersion in the data, there is variability in the data. This is how we can define dispersion of a data, which means spread out of data or variability of data, or in terms of Dr. Bowley, it is a measure of variation of the item. I hope we have got the meaning of dispersion with the help of these example. आपको ये समझ में आया होगा. Now, what are the different methods of dispersion? We will learn now those methods. And there are absolute and relative measure of dispersion. Absolute measure of dispersion. Absolute measure of dispersion. In absolute measure of dispersion, we measure the dispersion of data, the variation of data with respect to original unit of data. In short, we can say absolute measure of dispersion is the variability of data, variability of the items in a given series in terms of original unit of data. And second one is relative measure of data. Relative measure of dispersion. Relative measure of dispersion. Now, relative measure of dispersion, we measure dispersion of data, the variability of data in relation to some other relative value or in percentage. In short, we can say the relative measure of dispersion is the measure of variability of data in relation to some other value, relative value, or in terms of percentage. And in absolute measure of dispersion, we will learn the different methods of dispersion such as range, such as standard deviation, quartile deviation. The first method of measuring dispersion is range. We will start from range. Methods of measuring dispersion. Number one is range. What is range? It is the difference between largest value denoted by L and smallest value. Range is the difference between largest value and smallest value denoted by S, or we can say it is the difference between highest value and lowest value. Therefore, we can write a range is equal to or denotes range and is largest value, or we can say highest value minus smallest value, or we can say lowest value. In simple, the difference between largest value and smallest value gives us the value of range. Here the value of range, here is the dispersion of data. And coefficient of range is equal to largest value minus smallest value divided by largest value plus smallest value. For example, the data given is statistical information given is weight of some persons in kgs, 20, 30, 50, 60 and 80 kgs. Range will be equal to the difference between largest value and smallest value, that is L minus S, and value of range will be equal to the largest value, the highest value in this data is 80 kgs minus the smallest value is 20 kgs. it will be equal to 60. The value of range will be equal to 60. And coefficient of range is equal to largest value minus smallest value divided by largest value plus smallest value, or highest value minus lowest value, highest value plus lowest value. The largest value in a given distribution, in a given data, is 80. Smallest value among these values is 20. Divided by the largest value among these values is 80 and smallest value among these values is 20. It will be equal to 80 minus 20, it is 60, divided by, so this is plus, divided by 100. This and this will cancel. It will be equal to 0.6 coefficient of range. This was how we can calculate the value of range at coefficient of range with the help of this formula.